As you can see from the title of this lesson, this tutorial is about significant digits and rounding. These are two very important ideas as we move into topics in chemistry that will have us start using math to solve different types of problems. The key thing about working with sig figs is getting the hang of it right away and then just using it over and over again. Right? Where people start to run into trouble is if they start to make mistakes early on, they have to correct those mistakes and then kind of relearn what they've done. So it's much easier to pay attention and get through this the first time. That way you have a good foundation to build on. If we're going to talk about significant digits, right, there are two important things that significant digits, or sig figs, because sometimes they're called significant figures, will tell us about. The first thing that significant digits tell us about is the accuracy of an instrument. The type of device that we use to measure certain things is of great importance. For instance, if I'm going out to the track and I would like to time somebody in the mile, a stopwatch would be a great way to do that because it would tell me minutes, seconds, tenths of seconds, and even hundredths of seconds. It's a little bit of overkill though, because very rarely will the difference in a mile race be in hundredths of seconds. I could probably get away with just a second-hand clock for figuring out the time of a mile. But as you get into a race, for instance, like the 100-meter dash, you may have an entire heat of 8 people all finish the race in 11 seconds. Right? Somewhere, 11.1, 11.5, 11.7. Right? So if I were to use just a second-hand clock, that would not be accurate enough to tell the difference between the winner and the loser just by looking at the clock. Right? So the accuracy of the instrument determines how many significant digits the numbers get to have. A stopwatch gets to go 2 places past the decimal. An hourglass simply can tell us about 1 hour. A watch most often can tell you about minutes and seconds. Right? Other things that significant digits relate to are the precision or importance of numbers. If you think into the field of pharmaceuticals, we are talking about giving doses of Advil that are in the milligrams, right? Take 600 milligrams. Well, if you think about it, that's a relatively small number. A milligram is 0.001. Well, if I'm trying to measure that on a balance, right, in our room in the back, we can't do it. Our balances, as good as they are, only go 2 places past the decimal. Imagine somebody trying to measure out that amount of things on a scale that you weigh yourself, which only lists things in pounds. So as you get into measurements that require very, very precise amounts of things, because 600 milligrams of Advil may cure a headache, but 2,000 milligrams may cause some serious medical problems, you have to understand that the number of digits that we list as significant is very important. So how can we tell if a number is significant or not? There's an overhead that goes with it, so I suggest that you go into the overhead section and print it out, but I'll sum it up here as we go through. First rule of sig figs. All non-zero numbers are significant. The only number that we use that has the ability to be insignificant or not count is 0. Right? So if I look at a number that only has non-zero numbers, every single number that I see is a significant digit. For instance, if we look at the example, 193. as I analyze that number, I have to look at it and say, are there any zeros? The answer is obviously no. Right? So to figure out the number of sig figs that this possesses, I have to look at 193 not as one number, but as three separate numbers, a 1, a 9, and a 3, none of which are a 0. So if 1, 9, and 3 are all significant, that means this number has 3 sig figs. Second example, what if we looked at something like 2,946? Again, 2946, we look at each number individually. Are any of them zeros? No. That means a 2 counts, a 9 counts, a 4 counts, a 6 counts. Therefore, this number has 4 sig figs. Right, so the first rule you have to remember is all non-zeros are significant. Rule number 2, if the only number that can be insignificant is a 0, we have to decide when is it that a 0 doesn't count. Rule number 2, okay, zeros. Is insignificant and next to that, all right, doesn't count. In 2 conditions. Condition number 1, you have a decimal number, meaning smaller than 1, and you have yet to hit a non-zero. A good example of something like that could be something along the lines of 0.0013. Again, I will break that number down into the 4 numbers that make it up, 0, 0, 1, and 3. Right? Now, as we look, we have to decide, right, are the zeros there significant or not, because we know the 1 and 3 are going to be. What this rule here is saying is if I have a decimal number, something smaller than 1, which I do, I don't start counting sig figs till I hit the first non-zero. So if I say 0.0, I've yet to hit a non-zero. This one does not count. 0, again, I have yet to hit a non-zero. This one does not count. 1, I've now hit a non-zero, which means everything after that will count. So in decimal numbers, you don't start counting sig figs till you hit the first non-zero. This would have 2 sig figs. If we looked at another one that would be similar to that, take a look at the number 0.000120. You look at that number and you say to yourself, is it a decimal? Yes, it's smaller than 1. You don't start counting sig figs till the first non-zero. So does this 0 count? No, I haven't hit a non-zero yet. Does this one count? No. Does this one count? No. Now I hit a 1, which always counts. A 2 counts. Now we hit another 0, and we have to decide if this counts. As soon as you hit a non-zero, everything after counts, which means this 0 will count. So this number would have 1, 2, 3 sig figs. Right? So the first case where a 0 will be insignificant is as if it is a space filler, if it is just making a number smaller, right, before we actually hit a significant number. Right? The second instance where a 0 can be insignificant is if there is a large number with no decimal zeros at the end do not count. For instance, if I looked at the number 150,000 with no decimal. You start to look at this number, you know the 1 and the 5 are significant because all non-zeros are significant. We have to decide, do those zeros count? Right? With these zeros here, this is a large number, meaning greater than 1. Right? It has no decimal, right? And if there is no decimal, zeros at the end of the number do not count. So this 0, this 0, this 0, this 0, all do not count. This has 2 sig figs. If I did the same thing, right, with the number 150,000 with a decimal, all of a sudden things change. Whenever you have a number bigger than 1 that has a decimal, everything counts, including zeros. Right? So here, 150,000 would all count. This would have 6 sig figs. The reason the decimal is so important is it tells us about the accuracy of the instrument. This number, 150,000, would be like somebody at a very large athletic event, like a FIFA soccer game, looking around and saying, I bet there's about 150,000 people here. Right? They could be pretty accurate about the 150, but they couldn't say, is there 151 or 147,000? They don't know. This number here is specific all the way to the ones. There was somebody at the gate with one of those little clickers keeping track. They could say there is exactly 150,000 people here, not 150,001, not 149,999. So those are your rules for sig figs. Where you'll start to see these rear their head more often is when we start to do problems with them. And we will look at a tutorial here where we talk about rounding numbers, right? And then how we translate finding the number of sig figs into a math problem in terms of what is going through. And that will be a follow-up tutorial to this about rounding numbers. Hope this helped out. If you had any questions, please feel free to come in and ask.